forget. So we're just going to start out here at the top. These are just radical equations, so they have a square root in them. So let's just, or a cube root. So let's see what you remember. So on this one, I've got 5 times square root of x minus 2, and then outside the square root plus 7 equals 8. What should I do first? Subtract the 7. Okay. All right, so I have 5 times the square root of x minus 2 equals 1. Okay, then what do you want to do? Divide by 5. So I have square root of x minus 2 equals 1/5. Sorry, I'll try and sneak that in there. What do you want to do after that? Square it. All right. You cannot add and subtract things out from the radical, so you can't like add the 2. You got to get rid of the radical. You're just going to square it. So I'm going to get x minus 2. Now, if you square 1/5, right, we're just going to square the top. So 1 squared is 1, and we're going to square the bottom, which is 25. And then obviously this does not have a nice answer. So I'm just going to grab my calculator. All I have to do, I have 1/25. I'm going to add 2 to that because I'm going to add the 2 to the other side. And I'm just going to do my math enter to make that a nice fraction. Or you can put the decimal. Either one is fine. So 2.04. I don't feel like there's any nasty numbers like that on the actual final, so don't worry about that. Or as a fraction, that'd be 51/25. Okay, my second question, I have a cube root. How do you get rid of a cube root? Cube, yeah. Okay, so I'm just going to take both sides to the third power here. It's the only difference. So the third root and the third power just cancel each other out. Anybody remember 2 to the third power? 8. And then this is just a normal equation. We're just going to subtract 6. So I get negative 3x equals 2. And then just divide by negative 3. So x is negative 2/3. All right, what do you want to do first? The next one's a square root again. What should I do first on number 3? Wow, don't everyone volunteer at once. What should I do first? I got 3 minus this square root 2x plus 1 equals 12. What do we think? Let's move to 3, right? Okay. All right, now I get this negative square root of 2x plus 1 equals 9. What should I do next? Get rid of the negative 1. All right. Can I have a square root equal to a negative number? This is that like an extraneous solution here. So I got a square root by itself equal to a negative number. If you square both sides, it will cancel that negative out. But if you plug the original or the answer into the original problem, it'll cause you to take the square root of a negative number. So this is going to be no solution. The square root cannot be equal to a negative number. A cube root can be, because you can take the cube root of a negative number, but a square root cannot be equal to a negative. Okay, now these guys are super easy. All right, this is just converting from exponential form to radical form or radical form to exponential form. So this says the 5th root of c squared. So exponential form, it would be c to what power? Not the 3rd. It's a fraction. Yeah, 2/5. Do you guys remember like the bottom out, I'm reversing that? So this becomes the 2/5 power. Like if you have like the square root of x is x to the 1/2 power. The index would be 2, and that would just be an x. So we're just reversing the bottom out. Now this notation looks different, but it's actually the same as this one. It's just written in a little bit different format. So I do bottom out. So if I'm going to reverse that, the index of the root is the bottom of the fraction, and whatever's with the variable is going to go on the top of the fraction. So that would be the same as b to the 5/3 power. All right, now I'm going to do the other way. So I've given you exponential form here, so we're going to reverse this and put it in radical form. So just bottom out, this would be the 4th root of x to the 3rd. That's all you're doing there. This guy is a little tricky. So this is to the 2, or the 3 over 2 power. So this would be the square root of x cubed. Now, if the number of my exponent is bigger than the root, that can actually be simplified a little bit. So see if you guys remember doing this. If you're working with the square root, if your exponent is divisible by 2, you can simplify it. Now, I know 3 is not divisible by 2. It's not a nice number. But if I break this apart, x to the third is the same thing as x squared times x. And I'm just trying to take out any perfect squares. So the x squared, the exponent divided by the root 2 divided by 2 would take out an x, but this other x would be left underneath. So that's kind of tricky on that one. All right, now I got kind of one of each. I got a square root, I got a cube root, and I got a fourth root. Tell me square root of 25. Okay, what about x to the 24th? What would you pull out there? X to the 12th. What would you pull out for y to the 8th? Y to the 4th. That's a perfect square, right? All the number was a perfect square, and the exponents were all divisible by 2. So that's just my answer, totally done. Okay, let me do just like one little thing with this one here. So I have a cube root, totally fine to do that for a negative number. I'm just going to rewrite it super quick. I have negative 1,000, which is not a negative exponent, it's just a negative number. I do have a negative exponent with the x though. So if I'm going to move it and lose it, I'm going to turn this into a fraction. This would be the same thing as x to the positive 9th underneath that negative 1,000. And then the y has a positive exponent. So it would just stay where it's at. So I'm just moving that negative exponent down. When I do that, the negative exponent disappears and you have x to the positive 9th. Okay, now, I promise, all these are perfect cubes. What would you tell me the cube root of negative 1,000 is? Negative 10. What would you tell me the exponent on y is going to be? 9. You just divide the exponent by the root. This is a perfect cube. What would you tell me the exponent on the x would be? 3rd. And then this would just be my answer. All right, now I know these are up on the board, or if you guys have those little yellow cards, I'll print that on the little sheet I'm going to have you guys use on the final if you want it, those little yellow pieces of paper we had. Does anybody know the 4th root of 256? It's 4. Okay, I promise whatever is on the final, it's a perfect, if it's a 4th root, it'll be a perfect 4th, or if it's a cube root, it'll be perfect cube, perfect square. What would your exponent on the x be if you had a 4th root here and I have x to the 20th? 5. What would your exponent on y to the 8th come out as? 2. So this would simplify 4x to the 5th y squared. Does anybody have a question? Okay. Now, here's what I'm going to do. This is 27 to the 2/3 and then x to the 12th to the 2/3. So everybody gets a 2/3 power. So 27 to the 2/3. Now, if you have power to a power, I'm going to multiply the exponents. So I'm just going to do 12 times 2/3. And you don't have to like break this down by hand. You can use a calculator, of course. So this is going to be 24 divided by 3, which is 8. So the exponent there would be x to the 8th. There's nothing more to do with that. All right, now we did a lot of this by hand with the number, but I'm going to see if you guys remember this. To do 27 to the 2/3, what you do, I'm going to do that bottom out. It is the cube root of 27 squared. If we give you something like this, I promise it will be a nice number. I would tell you to take the root first and then do the exponent. So what's the cube root of 27? 3. And then you would square it. So that would be 9. So that would be my answer then, 9x to the 8th. All right, so I'm going to do the same thing here. All right, so everybody gets this 1/4 power. So we have 81 to the 1/4. Now, if I do 28 times 1/4, it's like 28 divided by 4. So that would just become 7. And power to power, I'm going to multiply these. Negative 20 times 1/4, or negative 20 divided by 4, would make that y to the negative 5th. And I'm just going to move that underneath in a fraction here. The only other thing I have to simplify is 81 to the 1/4. So if I do the bottom out, that's actually just the 4th root of 81 to the 1st. So it would just be the 4th root of 81. Anybody know the 4th root of 81? I think it's 3, yeah. So this is just 3. All right, so here'd be my answer. The 3, the x to the 7th. And then because that y had a negative exponent, I'm just going to write that underneath those other two terms and get rid of that negative exponent by writing that as y to the 5th. Does anybody have a question at the moment? I know it's been a long time since we've done some of this stuff. Okay, now let's break down some radicals. So there's one question like this. There's a square root and there's a cube root here just to practice both. But totally up to you if you like to do a factor tree, or if it's me, I like to try and figure out the biggest perfect square. So like if I see 50, I just rewrite that real quick as 25 times 2. 32, the biggest perfect square that'll go in is 16. So I'm going to do 16 times 2. And then 18, the biggest perfect square would be 9 that would go into that. And then once I figure out the biggest perfect square that goes in, we can just remove that perfect square. So like 25, that would come out as a 5, 16 would come out as a 4, and 9, if I take the square root, would be 3. If you've already got something in front, what do you do with the number you pull out? Do you guys remember? Multiply. So this is going to be 10 square roots of 2. This one would be 12 square roots of 2. And then this one, last one would be, let's see, minus 30 square roots of 2. If they all have the same thing under the radical, you can literally just take the numbers in front. So I'm going to do like 10 plus 12 minus 30. So I'd get negative 8 if I put those guys together. That would be my final answer, negative 8 square roots of 2. All right, let's see if we can break these guys down. All right, so with a cube root, if you do want to do a factor tree, you could do that here too. If you do a square root, you're doing pairs. If you do a cube root, you're pulling them out in groups of 3. So I like to figure out the biggest perfect cube. So if I'm looking up there, if you guys are looking up on the board, it's that second list. Those are all perfect cubes. 192, I'm pretty sure is divisible by 64. So you can just check that on your calculator. So this is 64 times 3. And if you see something with a 5 in it, I would look like up there on that list, you got 125. I'm pretty sure that goes into 175, which it totally does. So this is 125 times 3. All right, so the first term, you couldn't simplify that at all. That was already done. This guy, now we're doing a cube root, so be real careful. Some of the numbers like 64 and 81, they're on multiple lists. If I'm working with a cube root here, I'm pulling out a 4. And 125, if I'm working with a cube root, I'm pulling out a 5. So after I take those guys out, sorry, I should have given us a little more space here. You got 4 cube roots of 3 minus 24 cube roots of 3, and then plus 40 cube roots of 3. So initially when I did the problem, they didn't look like radicals, but they all end up being if you simplify. So all you're going to do 4 minus 24 and then plus 40. So if I simplify this, don't change what's under the radical. It should stay a cube root of 3. Is anybody having a question? Okay, now these guys, you can only add or subtract if you have like radicals, but you can always multiply. So if I'm going to multiply here, this is just a little distributive property. What am I going to get if I do the square root of 8 times the square root of 3? Do you remember? 24. Exactly. You just multiply the numbers. So this would be 24, and then minus square root 8 times 6 is 48. Then you're just going to see if we can break them down at all. So 24, biggest perfect square that goes into 24 is 4. And let me think, biggest perfect square that goes into 48, that is 16. All right, these are not going to be like radicals, but they can be simplified. So this first one, I'm going to pull out a 2. The second one, we're going to pull out a 4. So my answer there, I would have 2 roots of 6 minus the second one would be 4 roots of 3. We can't go any farther than that because what's under the square root is not the same. All right, let's try just one more like this. I'm gonna distribute. You can always multiply. You just multiply both of the numbers under the square root. So I'm gonna do 15 times 5, which I think is 75, yes. So this first term would be square root of 75. And then 5 times 12 is 60. Factor tree, if that's your jam, or if you want to do biggest perfect square, for 75, biggest perfect square that would go in is 25. And for 60, I think the biggest perfect square is just 4. So it'll be 4 times 15. Now, these will not be able to add, but we can simplify. So for the 25, I'm going to take out a 5. For the 4 square root, we're going to take out a 2. So that first term would be 5 roots of 3, plus the second term would be 2 roots of 15. So it can be simplified, but we can't actually add those terms together because they're not like radicals. All right. Now, the 2 at the bottom, do you guys remember how to do? I've got 8 plus the square root of 2 times 1 minus the square root of 2. What kind of a process would you maybe use to multiply those two? Yes, you can do FOIL or you can do a box, either one. So I just think of FOIL as like a little double distributive property. If you want to write a box, you can write a box. So 8 times 1 will be 8, and then that negative in front of the root 2, I'm just going to write a minus. 8 roots of 2, you just put the 8 in front of it. All right, then I have square root of 2 times 1, so that would just be 1 square root of 2, or just a square root of 2. And then you have a plus and a minus, so positive square root of 2 times negative square root of 2, this would be minus. 2 times 2 is 4. All right, now these guys are like radicals in the middle here. You got negative 8 plus 1, so we got negative 7 roots of 2. Now this term on the end, it's minus, but that's a perfect square, right? So we're just going to pull out a 2. The only other thing I could do there is put the 8 and the negative 2 together. Typically, you'd see the plain number out in front, so then 6 minus 7 roots of 2. All right, do you guys want me to do another one, or does that make sense? Because this is like the same problem. Okay, we'll skip this. Okay, now. These two pieces to this, I don't know if you guys remember this, but I'm just going to write this. These are called conjugates. All right, that literally they're exactly the same, except one has a plus and one has a minus. Like everything else is identical. And I'm just going to multiply this through, but hopefully you guys remember this. If you multiply conjugates together, all the radicals should cancel out. So you get 5 times 5, so I'd have 25. Then you get minus 5 roots of 7. Then you turn around and get plus 5 roots of 7. So those guys are going to cancel each other out. And then this is always negative on the end because one's always a plus and one's always a minus. But this should become a perfect square because you're going to do 7 times 7. So that's going to give you 49. The two guys in the middle are going to cancel each other out. So I'm going to get 25. Now, square root of 49 would be 7. So we're going to do 25 minus 7. And so 18 would be my answer. So we use conjugates for the questions actually that are right underneath here to cancel out radicals in the denominator if you have plus or minus. Okay, the question, you don't actually have to rationalize the denominator on the test. You just have to, and this will be multiple choice, you have to tell me what you would multiply by. So I would want to, in these two questions, cancel out the radical in the bottom. And this first one I think is really tricky because they're really similar. What you want to do is the conjugate of the bottom, because you can have a radical on the top. So the conjugate of the bottom, you're just going to copy the bottom, but change up that sign in the middle to be the opposite of what it was. Whatever you do to the bottom, you have to do exactly the same thing to the top. So if I was doing this on a multiple choice question, that's the one I would want to pick out. It should be the same top and bottom, and it should have the opposite sign of whatever's in your denominator. So same thing here. It doesn't matter what's on the top, just the bottom. If you do start with a negative number, like this is negative 7, you do not change that. You only change up the middle sign. So this would be negative 7 minus square root of 2. And whatever you do to the bottom, you have to do the same thing to the top, because that way you'd multiply by 1. If we actually went through and did that, it would cancel all the radicals out on the bottom, which is the goal of rationalizing a denominator. You guys don't actually have to do it, you just have to know what you would multiply by to do that question on the final. Does anybody have the question? Okay. Now, we're going to do a couple equations. You might want a calculator, but I'm pretty sure I have nice answers for these. So what I want to do, this is, I know you don't see a radical here, but this is a radical equation. It just has a rational exponent, which just means my exponent is a fraction. So here's how this works. Let me get that lovely fraction exponent by itself. So I'm just going to get rid of anything to the side. So let me move the 2. That would make this 48. And then I'm going to divide by 3. And you cannot add and subtract things out of this set of parentheses. So we're going to have to cancel it out. But we'll have a nice number when we do this. So I get x plus 1 to the 4/3 equals 16. Does anybody remember how to cancel out that exponent? If not, maybe what I could do, I could do my bottom out. Oh, go ahead. What were you going to say?
I was gonna kind of, the way I do it is kind of different, but, basically I just turn it into the root of x plus 1 to the 4th power, and then I keep both sides, and then 4th root both sides.
There you go. Perfect. Perfect. Okay. So we could convert that real quick, like the bottom out, exactly like she said, the cube root, that x plus 1, then whatever the top of the fraction is would be the exponent there, okay? You're just going to do 2 steps. We're going to take both sides to the 3rd power. And let me see what that is. 16 to the 3rd power is a huge number. You get x plus 1. We'd still have a 4th power on this, and I got 4,096. Okay, now we would take a 4th root. Now, if you guys introduce a square root into a problem, it's exactly the same concept as if I introduce a 4th root into a problem. You have to put a plus and minus sign. You can't forget that. So not if it's even, you got to put a plus minus. If it's like a cube root, you don't have to worry about that. But you introduce an even root, which is a 4th root. Okay, 2 ways to do this on the calculator. If you want to just do that 4096, the 4th root is the same thing as the 1/4 power. You could do that. Or if you want to get a 4th root, you would have to go into your math menu, and then it's the 5th one down where you can pick any index you want for the root. And I could type in a 4th root. You'll see I get the same thing, 496. The key to this question, though, this should be x plus 1 is plus or minus. And I got 8, because there's actually 2 answers to that question. Because I took a 4th root. If you take an even root, you got to put the plus and minus. So then, to get x alone, I'm just going to subtract 1 from both sides. I'm just going to write it right after the equal sign. So minus 1. And then to get your 2 answers, you're just going to do -1 plus 8. So that would be 7. And you're going to do -1 minus 8, which would be -9. I'm going to do one more like this, but this one's a little bit, it's not very different at all. We're going to need a plus and minus on this one. But get your parentheses alone. So I'm going to add 1. So I'm going to have that 2 times x plus 19 to the 2/5 power equals 18. We're going to divide by 2. You do not want to distribute anytime you got an exponent like that. 2/5, this will be 9. This is the same thing. I'm going to do my bottom out, the 5th root, x plus 19 squared. You don't have to FOIL that or anything, just leave it alone. What you're going to do, we're going to get rid of that 5th root by taking both sides to the 5th power, and this will be kind of a huge number. So do 9 to the 5th. You get x plus 19, that's squared, and then this is 59,049. And then to get rid of this squared, so this is really similar to that last question, we're going to take a square root. But I introduced the square root into the problem, so I got to put that plus and minus. So all I have to do here, you could do 1/2 power, or this is just a plain square root, that 5949. And I promise it'll be a nice number. We're not gonna give you something that's not. And then I just need to move the 19. So I need to subtract that. Sorry, I'm kind of bleeding into this other question. So you'd have negative 19 plus or minus 243. So if I do negative 19 plus 243, one of the answers is 224. If I do negative 19 minus 243, my other answer is negative 262. Sorry, that was kind of long. Does anybody have a question? Okay, we're almost done. I know, sorry, it's a lot. All right, this is what we just got done doing with our inverses, like the other day. You're just gonna switch x and y and solve for y. So just get y by itself on one side. So it's not in function notation or anything like that. It's just y equals. So we're just going to switch x and y real quick. So I'm going to write x equals 1/3 y squared minus 2. So that's the inverse, but I got to get y by itself to actually write it in the proper format. So first thing I would do, let's just add 2. And so I'd have x plus 2 equals 1/3 y squared. Okay, we're going to take a square root in a second, but you want the y squared all by itself before you do that. How would you get rid of the 1/3? Anybody know? Like, how do I get rid of 1/3? Multiply by 3. Okay, now, you just got to do it to everybody on both sides. So we're just going to multiply everybody by 3. So it'll just cancel it out on the right side there, but we'd have 3x plus 6 equals y squared. Then all you have to do, just one step, you're going to take a square root, but you got to remember, if you introduce the square root, you have to put that plus and minus sign. So I would have y equals plus or minus, excuse me, just the square root 3x plus 6. You're not doing anything else there. You can't take a square root. There's adding inside that square root. Just leave it alone. Don't factor anything, whatever. That's just your answer. Okay. Here, I'll tell you what, let me do one more. This is super similar, but it's also quadratic. So I'm going to switch x and y. I'm going to write x equals 10y squared plus 9. This one's going to look just a little different. I'm pretty sure the one on the final is more similar to this one, but let me not promise that, but I'm pretty sure. So you're going to subtract the 9. Now this is the part I think that's a little bit weird. How would you get rid of the 10? Divide. Okay, now here's what you can do. Just leave it like that. Don't try to do anything else. You can't simplify that. Just leave that big fraction. And then what we're going to do to get our answer is take the square root of the y squared when we do that. Don't forget your plus minus, but just you can leave this whole, you don't have to rationalize or anything. I'm pretty sure that's the format that the answer's in on the test. So just leave it like that, like no rationalizing the denominator. Don't worry about that. All right, the last thing you're going to have to do, graphing radicals. So we did 2 types. We did square roots and we did cube roots. So you just got to remember the shape. These first 2 are square roots. So in general, if you have a positive square root, to make it a function, we don't have the plus and minus in front of it. That is the general shape. It is like the top half of the sideways U, but we restricted it when we graphed it so we had a function. What you're going to do, opposite copy, inside with the x, it's the opposite of what that looks like. Outside, just copy that number, and that'll be the starting point. So I'm going to go, this is -2, -1, and then you're just doing a little sketch. You're not going to have to graph anything like specific points other than that first one. We're just looking for that general shape. Now, your domain, you don't touch any part of that graph till you get to the x value of that point. And it would be a bracket because I actually have a point there. So from -2, and then it just goes to the right forever, so to infinity. The y, very similar. You don't touch any part of that graph till you get to that starting point. The y coordinate there is -1, and it goes gradually, but it does go up forever, so that also will go to infinity. Yeah.
Can we do the opposite sign of what's in the radical?
Yes. Okay, fired. Okay, don't look at this graph. Or no, here's what I'm going to do. Here's what I'm going to do. Change this to a plus. Just change this to a plus on the inside of that. Just change that. We'll do it that way. We'll do it that way. We'll just change that. Okay, that's easier than redoing the whole thing. We'll just change that to a plus. Yes, go right ahead. All right, now this one, you guys, if you have a negative in front, so see this is still a square root, but a little negative in front, you can do this. It's just the bottom half of that sideways U. So it's just, it would be a reflection of this. It's just going to be the bottom half. Now, pretend I did this correctly. Now, if I actually did my opposite copy correctly, this one would be -5, +1. So it'd be like right here. And then it would just kind of swoop down to the right. The domain is going to be identical to what you just did. The first x value you touch should be the x value, that starting point, which would be -5. And even though it's going down, it's still going to the right forever. What would be different here is now your range, this is pointed down, so the range would start with -infinity, and then you would stop touching the graph at that point where I started it right there, which is 1. So it's flipped over from what we just did. All right, now the cube roots are super easy. They have the same domain and range no matter what. And what I have here, the general shape, if you have a cube root, it like swoops up to the left and then it swoops up to the right and swoops back to the left. So it's kind of like a squiggly line. The opposite copy is going to give you that point in the middle. So in the middle there, opposite copy would be +3, +2. And so we're just looking for that general shape. So that was just the shape of a cube root just that I drew above the graph. So you can take the cube root of a negative number. That's why it can swoop both directions. Whereas a square root, you can only take square roots of positive numbers and get a value. Otherwise, it's imaginary. So that's why the graph for the square roots only goes one direction. Now, this left and right forever, so -infinity to infinity. Same thing for the range. Up and down forever. The only thing that's going to be different on this last question, if you have a negative in front of the cube root, it just flips over what we just did. So this one would flip up to the left and then like down and forward to the right. But that middle point would be your opposite copy. So this would be -2, -3. And I'm just going to flip the direction. So this will be up to the left and down forward to the right. The domain and range are identical. It still goes left and right forever, still goes up and down forever. It's just flipped a different direction to start.